Today we will be discussing about combinatorics. So we have already discussed descriptive statistics, diba? We have already tackled and discussed how do we get the different statistical measures, diba? The mean, the median, the mode, the measures of variability, measures of position, okay, even the skewness and kurtosis. So before we go into inferential statistics, we have to discuss first probability. And before we discuss probability, we need to know what is combinatorics. Okay, so when we say combinatorics, this is the branch of mathematics that deals with the arrangement of elements in a set. Okay, so if you can remember, di ba, sa ating, sa set theory natin, di ba, I think this was discussed during mathematics in the modern world, di ba? Say, for example, I have this certain set, let's say this is set A, okay, and I have my elements 1, 2, 2, 3, 4, 5, 6, 7, say. Okay, so kunwari yan yung mga elements na meron ako sa set ko. So, in combinatorics, we basically discuss how do we arrange these elements, no? So, whether it is in a linear arrangement, circular arrangement, etc., etc. Okay, so combinatorics involves counting, okay, permutation, and combination. So, yan yung mga i-discuss natin ngayon, no? In combinatorics. Okay, let's first discuss fundamental counting principle. When you say fundamental counting principle, this is the way for us to determine how many possible outcomes do we have given certain number of circumstances. So, sabi dito, the number of outcomes is equal to m times n, where m and n are the possible options, no, for us to place something. Now, for example, sabi dito, how many ways can you arrange 5 books in a shelf? No, so yeah. So, say, di ba, kung meron ka 5 books, no, let's say yung 5 books mismo ang i-arrange mo. So, meron kang 5 spaces. Okay, yan. Meron kang 5 spaces. So, from these 5 spaces, no, let's first look at the leftmost or yung pinakaunang space. But usually naman, left to right naman tayo naglalagay. So, on the first space, kung meron kang 5 books, ilang possible books or rather ilang books, ilan yung pagpipilian mo ng books na ilalagay mo. So, di ba, of course, you have 5. Di ba? So, you start with 5. Kasi nga, 5 yung pwede mo ilagay. Then, once na naglagay ka na ng isa, syempre, mababawasan yung options mo. Di ba? From 5, magiging since isa yung nalagay mo, magiging 4. Okay? Pagkalagay mo ulit ng pangalawa, so that will become 3. Then, after ulit, pagkalagay, we have 2, then we have 1. So, sabi dito, the number of outcomes or the number of ways, okay, that is identified by m times n. So, ano ibig sabihin nun? We're going to multiply each other. So, this will be 5 times 4 is ilan? 120 times 3. 20 times 3, that is 60 times 2. 120 times 1, that is 120. So, we have 120 ways to arrange these 5 books initially. Okay? So, next. Tayo sa pangalawa. So, how many ways can you arrange 8 students sitting in a row? So, we have 8 students. Lahat sila ilalagay natin dun sa 8 row. So, we have how many spaces? 8. Ayan. So, we have 8 spaces. So, again, following yung idea natin dun sa number 1. So, how many options do we have for the first place? Now, syempre, you start with kung ilan yung option mo. So, that is 8. Then, pagka-place mo ng isa, babawas ka ng isa kasi nalagay mo na eh. Hindi mo naman na pwede ilagay ulit. Diba? Especially tao yung pinag-uusapan. Ayan. 8, 7, 6, 5, 4, 3, 2, and 1. Then, we're going to multiply each other. Okay? So, of course, medyo tricky na kapag marami. Diba? Pero, if you're going to look at this, we are multiplying the number to 1 step lower, diba? We subtract 1 from the previous number. So, from 8, multiply 7, 6, so on and so forth. This is similar to what? Sige nga. Isip. Diba? This is similar to what? This is similar to a factorial. Diba? So, if you can remember, diba, yung factorial natin, Diba? We start, let's say, 3 factorial, that's 3 times 2 times 1. So on and so forth. Okay, so meaning, itong part na to, this is also a factorial. No, factorial yung ginagamit. So using the calculator, okay, so look at the calculator. So 8 shift, asa na yung ito, nasa may x raised to 1. So that is, ayan. So that is 40,320. Ayan. So we have 40,320 ways to arrange 8 students, no? Ganun karami. Ayan. Okay, and last, no? So, how many arrangement can you make from 10 pens, no? So, hindi na natin isa-isahin to. Diretso na tayo kay factorial. So, this is equivalent to what? So, let's use the calculator. Ayan. So, this is 3,628,800. Okay, so, imagine 10 pens lang yung ayusin mo, pero you have more than 3 million ways, no, to arrange those 10 pens. Okay? So that is the idea of the fundamental counting principle. Okay? So, let's talk about events. No? When we arrange something, okay, at that specific time event, or rather at that specific time frame, no, we're talking about events. No? So, when we say events, ito yung mga bagay na yung mga outcomes na nangyayari on a given time, given specific time. Okay, so we have two types of events. We have mutually inclusive and we have mutually exclusive events. When we say mutually inclusive, these are events that occur together, no? Meaning sabay sila nangyayari. Okay, for example, let's say group A, I have, let's say, 4 balls. For B, let's say I have for group B, I have, let's say, 5 balls. Okay. So, sabi, no, for example, for mutually inclusive events, no, so, if we're going to arrange A and B at the same time, okay, at the same time, okay, so, di ba si A, this is, A is 4 factorial. Tama, kasi apat yung elements ni A, so, if we're going to arrange those 4 balls, that is 4 factorial. Then we have for B, that is 5 factorial. Okay, if we're going to arrange them, A and B, no, at the same time, meaning sabay mo sila i-aayusin. Okay, that is mutually inclusive events. No, so pag mutually inclusive, from our formula, n is equal to n sub 1 times n sub 2, so on and so forth, so you're going to multiply. Okay, so we have 4 factorial times 5 factorial. Okay, so that is 2880. If they are mutually inclusive. Okay. However, if they are mutually exclusive, meaning they do not occur together. Meaning, no, ano ibig sabihin ng do not occur together? Arrange ko muna si A. Pag na-arrange ko na si A, that's the time that I will arrange B. Okay? Hindi sila sabay aayusin. No? So, pagka ganun, okay, ang operation in between is addition. Okay, so, for this, for example, inayos ko muna si A. Tapos siya kung ngayon naayusin si B. Pagka, ang the idea kasi here is, you're going to arrange A with B having a fixed value. Or rather, fixed arrangement. Then once you are done arranging A, mafe-fix ngayon yung arrangement A, si B ngayon ang aayusin mo. Okay? So, gumagalaw ba si A habang ginagalaw si B? Hindi. No, so kaya addition yung gagawin natin. Okay, so for addition, so this is instead of multiplication, that is 4 factorial plus 5 factorial. Okay, so that is 144. See the difference? Diba? So, of course, pag mutually inclusive, mas marami ka talaga makukuha, especially if you have larger elements, diba? Larger number of elements. Pag mutually exclusive, talagang konti yan. Kasi nga, diba? Hindi mo sabay inaayos eh. Okay? So, yung isa, ayos na. Pag inaayos mo isa, and vice versa. Okay? Sige. So, you have the idea for the events of fundamental counting principle. Now, let's go to combination. Okay. In combination, arrangement of elements wherein the order, ito yung pinaka-importante dyan, the order does not matter. Meaning, no, wala tayong pake kung merong magkabaliktad. Okay, we just count them as one. For example, I have four letters, A, B, C, D. No, so let's say I need to arrange, let's say, three letters. No, so that will be A, B, C, A, C, D. Sorry. Let me erase this first. Excuse me. So A, B, C, A, C, D, A, B, D. Ayan. Tama na? Okay, then we have uh, B, A, C, B, A, D, B, C, D. Ayan. Okay, then, ano pa? Um, sorry. So we have CAB, CBD, CAD. And last, no, we have what? DAB, sorry. DAC, and DBC. Ayan. Okay? So, DCB, meron pa ba? Meron na ba ako DCB? Dadagdagan ko pa. Ayun, to rearrange pa din kasi. ACB. Ibang count pa pala sa ACB. Ayan. Ano pa? EDC. And we have ADB. Ayan. Dito, we have BCA, BDA, and BDC. Dito, we have CBA, CDB, and we have CDA. Then dito, we have DBA, diba? Then we have DCA and DCB. Yeah. So, in combination, meaning, diba, order does not matter. Basta they have the same element, we will count them as one. Ano yung mga same elements natin? Itong una. Diba? Likewise, ito. Actually, hindi lang yan, ano? Pati yung nasa baba. They are of same elements. Yan, ayusin natin. So, let's mark na lang ng different colors yung pare-parehas. Okay. So, ACB. Lahat na merong ACB, regardless of the arrangement, mark mo ng isa. Ayan. ACB, 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 ACB. Wala na. Okay, next. So, lahat ng naka-yellow, meaning, they only count as one. Okay, next. Lahat ng ADC. ADC. Ito, ADC din to. Then ito, dito, meron tayo ADC. Ito. Next. So, we have ADB. No? So, again, basta may ADB, regardless of the arrangement, ADB. Ayan. Okay, and last, no? We have, excuse me, BCD. Ayan. So, in total, how many colors did we arrive with? No, so we have yellow, green, yellow, red, green, and blue. So, for 4 letters with 3 with 3 letters to be arranged, so we have 4 combinations. No, so paano natin makukuha yon using this formula? No, of course, you do not need to list, no? Kasi, paano kung sobrang dami ng elements, diba? That would take time. So, we can use this formula. Okay, so, ang palatandaan natin dito is from N. Ito yung tandaan ninyo. From N, okay, choose R. So, para malaman ninyo ano yung magiging N and ano yung magiging R, basically. Okay, wait lang. Ayan. So, let's say, no, sa nakalagay sa problem, you have so, for example, say, nakalagay, no, from, let's say sorry, from 6, choose 3. No, so that is 6C3. Okay, ganun natin siya babasahin. Okay, 6C3. So, with that, that is n factorial. The formula is n factorial over n minus r quantity factorial r factorial. So, that is 6 factorial over 6 minus 3 factorial 3 factorial. Okay? So, that will be 6 factorial over 3 factorial times 3 factorial. Okay, if you input that into the calculator, so that will be 6 factorial over 3 factorial times 3 factorial. Yeah. So that will be 20 arrangements. Diba? From this example, yung letters natin, also that is, from 4, choose 3. Diba? So that will be 4 factorial over 1 factorial times 3 factorial. Kasi diba, 4 minus 3 is 1. So 1 factorial is 1. So just simply put 4 factorial, diba, over 3 factorial. Okay, so that will be 4. Okay, ilang colors ba nag-arrive tayo kanina? 4, diba? So we have yellow, red, green, and blue. So that is how we compute for the simple combination, no? Let's have some examples, no? So for number 1, how many ways can you pick 3 balls from a bag of 10 balls, no? So that will be from 10, okay, choose 3. So that is 10 factorial over 10 minus 3, that is 7 factorial times 3 factorial. So directly input to the calculator, so that is 10 factorial, okay, over 7 factorial times 3 factorial. Okay, so that is 120. Okay, pag hindi kayo pwede gumamit ng calculator, no, ang best solution natin dito is, okay, look for syempre sa numerator, diba? Ang goal kasi pag wala kang calculator is to lessen yung mga unnecessary factorials, no? Remember, 10 factorial, that is equivalent to what? 10 times 9 times 8 times 7 factorial. Diba? Ang kadugtong nung 8 is 7, 6, 7, and so on and so forth. Which is also equivalent to 7 factorial. Divided by 7 factorial times 3 factorial. Which will lead to the cancellation of 7 factorial. So that will be simply 10 times 9 times 8 over 3 factorial. So what is 9 times 8? So that is 72. Tama ba ako? 72. So that is 720. Okay, over 3 factorial is, is 6. Which will yield to 120. Ayan. Okay? So, yun yung mano-mano computation natin for a combination. Next, number 2. So, syempre, for this, puro calculate na lang tayo para mabilis, no? So, how many ways can you award gold, silver, and bronze medals from 7 contestants? So, sabi, from 7, ilang medal ba i-award? Naka-specify ba kung, tawag dito, may arrangement ba kung mauuna si gold, si silver, or si bronze? Wala naman eh. 'Di ba? So, that is simply choose, no? So, that is 3. We have 3 medals. So, that is 7 factorial over 4 factorial times 3 factorial. Which will give us 7 factorial over 4 factorial times 3 factorial. Yan. So, that is 35 arrangements. Okay? I hope you get it, guys, no? And for number 3, how many boards? Yung talking the boards dito is yung board of officers, ha? How many boards can you make from 15 nominees if there are only 8 members allowed to hold office? So, meaning from 15, 8 lang yung pipiliin natin, no? Regardless of the position. Okay? Regardless of the position. Kasi ibang bagay na kapag meron ng position. Okay, so kapag ganyan, that is simple combination. Okay, so that is 15 factorial over 15 minus 8, that is 7 factorial times 8 factorial. Okay, so n factorial over n minus r quantity factorial times r factorial. Okay? So, we have 15 factorial over 7 factorial times 8 factorial. Okay, so we have 6,435 ways. Ayan. Right? So that's how we array, rather how we do no simple combination. And when we say simple combination, okay, meaning once you have selected the element, you cannot reselect the element. Eh paano kapag pwede ang reselection? So that is what we call combination with repetition. Okay? Sabi dito, no, for simple combination, elements can only be selected once. In combination with repetition, elements can be selected more than once. Kasi 'di ba, syempre, especially pag tao or definite na bagay yung pinag-uusapan natin, of course, you cannot repeat the same element. For example, sa Board of Officers, di ba, syempre, natural lang na hindi ka pwede ma-re-elect sa isang position kapag na-elect ka na. Di ba? Hindi ka na pwede mapili once na napili ka na. Okay? So, kapag with repetition, this is the formula. So, repetition is denoted by the dito, yung prime, no? So we have NC prime R is equal to N plus R minus 1 quantity factorial. Yun yung nadagdag, no? Itong plus R minus 1. Yan yung nadagdag. Okay, dun sa formula natin. All over N minus 1 quantity factorial times R factorial. No? So for example, we have, ano ba yung best example nito? Ito yung ice cream. No? Mamaya. So discuss natin maigi sa ice cream. So number 1, the number of possible combinations, okay, with repetition of 3 objects from 5. So that is 5 C prime 3. Diba? So we have 5 plus 3, that is 8 minus 1, that is 7. Okay, over 5 minus 3 is 2 factorial times 3 factorial. So ilan to? So that is 7 factorial over 2 factorial times 3 factorial. So that is 420 ways. Okay, may malaking difference yan, no? Kapag ang tawag dito, kapag excuse me, without repetition kasi, no? So that is simply 5 factorial over 2 factorial times 3 factorial. So pag inedit natin, syempre mas onti yung choices mo, or rather yung arrangements mo. Ayun, no? Magiging 10 lang siya. Diba? So, yun yung main difference with repetition. No? So, ayan, sabi ko nga kanina, no, the best example dito is ice cream. Kasi, diba, sa pagbubili tayo ng ice cream, pwede tayo magpaulit ng flavor. Let's say, favorite natin mangga, palagi mo puro mangga lang. No? So, out of, let's say, mangga, avocado, and cookies and cream, no? Mangga lang ipapalagay mo. No? So, that is 3C1. No? So, kasi isang, not 3C2, not 3C1. Ilan nga ba? Let's say tatlong scope, no? So that is 3C prime 3. No, ganun. No, so eto, there are 8 different ice cream flavors from the ice cream shop. In how many ways can we choose 5 flavors out of these 8 flavors? Okay, pag ice cream, pwede ka umulit unless specified na hindi ka pwede umulit. Okay, so this is simply 8C factorial 5. Okay, so that is 8 plus 5 is 13 minus 1, that is 12 factorial over 8 minus 5, that is 3 factorial, 5 factorial. Okay? So, gamit lang natin itong formula na to. So, we have, that is 12 factorial, okay, over 3 factorial times 5 factorial. Ayan. So, that is dami. No, so that is 5, 2, 8, 0. So we have 665,280 ways, no? Yan, dami. To choose the ice cream from 8, not to choose 5 out of 8. Yan. Okay, so that is for combination. Now, let's go to permutation. Okay, kasi diba, sabi nga natin dun kanina sa combinatorics definition. No? So, this involves counting. Tapos na tayo. Okay? Combinations. Tapos na rin tayo. And permutation. Okay, so, in permutation, the arrangement does matter. Meaning, no, if we're going to go back dun sa example natin kanina, no, kung kanina dinisregard natin yung ibang arrangement, no, kasi basta meron kang same element Okay, that is good as 1. Okay, for combination. For permutation, that is not the case. No? So, kung ilan yung arrangement, no, they are considered as 1. No? So, ilan to? 1, 2, 3, 4, 5, 6. So, 6 times, ilan to? Times 4. So, that is 24. We have 24 arrangements. No? So, that is for permutation. Kasi, with the definition, no, for, this is from, ang ano natin dito, from, hindi ko pala nalagay, from N, pick up. No, yun yung pala tandaan natin. From N, pick up. NPR. So, we have N, no? So, yung kanina, di ba, we have 4 letters. We are asked to pick 3, no, to arrange. So, that is 4P3. Using the formula, so that is 4 factorial over 4 minus 3 factorial, which is, 1, no? So, that is simply 4 factorial. What is 4 factorial? Di ba, that is 24. So, try natin sa calcu. That is 4 factorial. Yep, we have 24. Ayan. Okay, so this is a simple permutation where no repetitions or no restrictions are allowed. Kasi we have different kinds of permutation. No? Ito din introduce ko sa inyo. This is the very simple permutation. Okay, ano ba yung different permutations natin? So, if all elements are selected, that is simply n factorial. Meaning, if we have four letters, at yung 4 na letters na yun ang i-arrange mo, okay, so that is simply n factorial or 4pn, 4p4, no? So, ito yun, yung npn natin dito. 4p4. If you're going to check, no? So, that is 4 factorial over n minus r factorial, so that is 0 factorial. 0 factorial is not 0 but rather 1, no? So, kaya which is simply dito, n factorial lang rin, no? Ayan. Pag with repetition but there are no restrictions, no? So that is np prime r, so that is n factorial over yung number of repetitions natin na naka factorial. Paano to? No, best example natin, no? Banana. Yan. In the word banana, no, ilang letters tayo dito? That is 2, 4, 6. But meron tayo repetitions, no? For A, ilang A ang lumabas? We have 3. And for N, we have 2. So, of course, since they are identical, we cannot determine kung ano yung nauuna sa hindi. Diba? So, we need to rule that out. No? So, the idea is, so for that is 6P prime 6, no? Kasi yung 6 letters na yun, i-arrange natin eh. Okay, so we have 6 factorial over 3 factorial times 2 factorial. Okay, that's the idea. Okay, ganun natin siya i-arrange. No? So, rather isosolve. So, we have 6 factorial over 3 factorial kasi tatlong A yung lumabas. No? Saan nanggaling yung 3 factorial? Dito sa A natin. Okay, and that is times 2 factorial. 2 factorial. Ayan. So, yung 2 factorial dito naman sa n, no? Dun sa letter n ng banana na galing. So, that is how many arrangements do we have? We have 60. Ayan. Kasi there is no way for us to determine what will be, kapag meron kang identical elements, no, which is nauuna. No, wala tayong way. Okay, then we have circular permutation without restriction, and yung condition natin is the clockwise arrangement is not equivalent to the counterclockwise arrangement. No, so later discuss natin to, but remember that the formula is for circular permutation n minus 1 quantity factorial. Okay, and kapag daw without restrictions circular permutation, okay, the clockwise arrangement is equivalent to the counterclockwise arrangement, so that is n minus 1 quantity factorial over 2. Ayan. Okay, sige. So, permutation examples. Number 1. How many ways can we arrange the letters of Alabama? No? Dito ko na lang susulat, no? Kasi wala tayong space. Ayan. Okay, so for number 1, how many letters yung Alabama natin? So, that is A, L, A, B, A, M, A. So, we have 7. So, obviously, this is with repetition. Diba? Classic example lang with repetition. Makikita ba? Ayan. So, 7 factorial, ilan yung umulit? So we have A lang naman yung umulit, which is 4. No? So we have 4 factorial. So 7 factorial over 4 factorial, that is equivalent to 210. So we have 210 ways to arrange the letters of Alabama. Okay, next, another classic example, Mississippi. So ilang letters sa Mississippi? I think that is 11. So let's count 2, 4, 6, 8, 10, 11. Yeah, we have 11. No, so we have 11 factorial over. No, so ilan yung mga, ano yung mga umulit natin? First, we have I. No, ilan yung I natin? 4. Times. Ano pa yung umulit? S. 4 din. Okay, and yung Mississippi. Yung P. No, so that is 2. Kasi dalawang P yung lumabas. Okay, so this is equivalent to what? So we have 11 factorial. Okay, over 4 factorial times 4 factorial times 2 factorial, which is equivalent to what? So we have 34,650 ways, okay, to arrange the letters of Mississippi. Okay, next. Now, how many ways can you arrange 3 books from on a shelf from a group of 7? No? So meron kang 3 spaces, itong book yung pwede mong pagpilian kung ilan yung ilalagay mo dun sa 3. No, so that this is simple permutation, so that is from 7, pick 3. Okay, so that is 7 factorial over 4 factorial. Tama, the formula for ano is n minus r. Diba? So we have that is 7 factorial over 4 factorial. Okay, so we have 210. Yun. Okay, so we have 210. Okay, next. No, so for number 4, how many ways can you arrange 5 students in a bench? Okay, if 2 students want to sit next to each other, ito na. No, so this is already with restriction. No, so how do we visualize this? No, so 5 students. 1, 2, 3, 4, 5. Okay, sabi, 2 students want to sit next to each other. No. Pag meron ganitong condition na meron dalawang magkatabi lagi na hindi sila pwede maghiwalay, you will count them as one element. No. So, with that, ilang elements na lang meron tayo na pwedeng arrange natin. No? So, that is 1, 2, 3, 4. Okay, so that is, this is will be 4 factorial. Kasi you have 4 elements to arrange. Diba? Okay, aside from the 4 factorial, of course, you need to take into account if the arrangement of the group is restricted. No, so meaning, sinabi ba na dapat yung dalawa ay yung dalawang student ay dapat yung isa lagi nasa kanan? Wala naman, 'di ba? Basta lagi lang sila magkatabi dapat. So ano meaning nun? Pwede silang magbaliktad. So ano gagawin mo? So times 2 factorial. Tama? Times 2 factorial. Kasi there are two elements na pwede mo i-arrange. Paano kung tatlo yung tatlo yung ayaw maghiwa-hiwalay? No, so that is 3 factorial. Okay, naintindihan po. So this is 4 factorial times 2 factorial. So that is 48. So we have 48 ways to arrange, no? Yan, eto. Okay, next. Okay, so this is number 4. Number 5. How many ways can you arrange 7 students? Nako, dumami. 7 students. If 2 students wants to sit next to each other but both does not want to sit with a certain person. Okay, so we have 7 spaces. 2, 3, 4, 5, 6. Okay, we have the first restriction. 2 students want to sit next to each other. Tama? Okay, so meaning ilan na lang elements natin? So 1, 2, 3, 4, 5, 6. So we have 6. Okay, hindi mo i-factorial muna. Bakit? You need to check if there is another restriction. Kasi meron dito, both does not want to sit to a certain person. Meaning, okay, let's say, meron silang kagalit na ayaw nilang katabi. Since hindi sila pwedeng mapupo dito, mababawasan nyo yun yung options natin. So instead of directly going to 5, diba kasi diba the idea is 6 times 5 times 4 times 3 times 2 times 1. Diba for us to create the 6 factorial. Okay, hindi 5 yung susunod, but rather magiging 4. Kasi meron kang isang hindi pwedeng maupo sa tabi nila, meaning hindi siya kasama sa choices. So ilan na lang? 4 na lang yung may iwan instead of 5. Okay, now, pagkaupo nung isa, let's say na-fill in na yung gap, no, may naupo na dun sa dalawang magkatabi na pwedeng maupo dun sa dalawa. Okay, bibilangin mo na ulit yung pangalawa. Yung hindi mo binila nung una. No, bakit? Kasi may naupo na dito. No. Pwede na siya umupo sa susunod. Kasi ang condition lang naman, bawal siya maupo with a certain person. Naintindihan? Okay, so that is times 4 na ulit. Okay? Then, yung susunod, wala na tayong problema. Okay, times. You need to again check, no, if yung naka-group is restricted. No, since hindi sila restricted, that is 2 factorial. Okay, so we have 6 times 4 times 4 times 3 factorial. Kasi diba 3 times 2 times 1 is 3 factorial times 2 factorial. Ayan. So that is 1,150 ways, no, to arrange with this certain restriction. Ayan. Okay, naintindihan po? Okay. So, another example, no? So, how many ways can you arrange 6 card players around a poker table? So, meron tayong certain discriminatory, but distinguishing word, no? So, we have here around. And when you say around, automatic, this is what? A circular permutation. Oops, sorry. Yan. So, there are 6 card players. Yan. Okay, the thing kasi with circular permutation is you cannot really determine where does the arrangement starts. No, kasi if you're going to look at this, okay, let's say kunwari hindi mo nakita kung paano ko sinulat, no? Hindi mo alam kung alin dyan yung una, sino yung unang element. Okay, so the idea is you're going to set one element, as your pivot element. Pag sinabi nito pivot element, din natin siya kasama sa bibilangin natin sa arrangement. Hence, we have the formula n minus 1 factorial. So this is, okay, diba? This is circular permutation. No, so, oops, sorry. Ikabrahin ko lang yung nasulat ko. Ayan. So we have 6 minus 1 factorial. Kasi nga the idea is, if we have 6 and we set 1 as pivot element, di ba? Ilan na lang yung pwede may arrange? Ilan na lang? Di ba? So that is, 5 na lang. So we have 5 factorial. So how many arrangements did we arrive with? Ayan. So that is, we have 120 ways. Ayan. Okay, we have 120 ways. Next, how many players can you arrange? How many ways can you arrange 6 players around the poker table if 2 players want to sit next to each other? Okay, so we have 1, 2, 3, 4, 5, 6. Okay, let's say, itong dalawang to, bawal sila maghiwalay. Lagi sila dapat magkatabi. Okay, lagi sila dapat magkatabi. Sabi natin kanina, di ba, we count them as 1 kapag meron tayong grouping. That's also the way, okay, for this. However, the idea is you're going to set this grouped element as your pivot element. Okay, so, para hindi ka na malito. No, so, sila na yung gawin mo pivot. So, ilan na lang yung i-arrange mo? 4 na lang. Diba? So, we have 4 factorial. Okay? However, you need to consider these 2. No, pwede ba sila magpalit? Yes, definitely pwede sila magpalit. You need to take that into account. Okay, so that is 4 factorial times 2 factorial. So that is 48. So we have 48 ways to arrange. No? Pag meron kang dalawa na hindi pwedeng magwala. Okay, and last, how many ways can you arrange the beads of a bracelet containing 6 beads? Now, so, excuse me, dito pumapasok yung if the clockwise arrangement is the same as the counterclockwise arrangement. Of course, pag tao ang pinag-uusapan in circular permutation, there is no way that the same person will sit on the left and the right of a certain person. 'Di ba? Laging, for example, yung best friend ko, lagi lang siya nasa kanan ko or nasa kaliwa ko. Hindi siya pwedeng mag-exist at the same time sa parehas. Okay, unlike kapag mga bagay ang pinag-uusapan natin. Best example is bracelet. No, sa bracelet kasi, di ba, there is no way unless it's super identical. Pero let's say, kunwari, only distinguished by color. No, so, there is no way for you to identify which is which pag in-arrange mo na. Okay? So, pagka ganun, again, the formula, no, pagka equal yung, I mean, identical yung arrangement, no, so, n minus 1 factorial, okay, over 2. So, yun yung gagawin natin for bracelet, no, kasi nga, hindi mo malalaman which is, ano yung left and right. Okay, so, that is for number 3. So, that is 6 minus 1 factorial over 2, which is what? So that is 5 factorial over 2. So that is 60. Yeah. Okay, so that's it for the permutation, or rather for combinatorics. Okay, I hope you guys learned something. Okay, so if you have, I mean, if you have questions, chat or comment down. Okay, there are lots of examples available in the internet. You practice. Okay, so thank you everyone. Stay safe and